Hello, I'm John Klobuchar with InEight, and I'd like to welcome you to the latest webcast in our Planning, Scheduling, and Risk series. Today's webcast is titled, How You Ensure On-Time Contractor Delivery with AWP. Our presenter today is Dr. Dan Patterson, who is InEight's Chief Design Officer. In this role, Dan focuses on expanding upon his vision of creating next-generation planning and scheduling software solutions for the construction industry. Dan is a certified project management professional by the Project Management Institute. If you have any questions as you watch the webcast, you can email them to webcasts@inneight.com, and Dan will do his best to answer them. Also, this presentation is being recorded, and we'll be sending you a link to the video in about a week's time. Once again, we're glad you have joined us, and now let me introduce Dan Patterson.
Well, thank you, John. So this is our second webinar in our AWP, or Advanced Work Packaging, webinar series. And today we're really focusing on how AWP can bring value and improved forecasting ability to the contractor organization. So when you think about a CapEx project, it's actually very interesting because, when we think about the relationship between the owner and the contractor or subcontractors, ultimately the project investment is owned by or carried by the owner organization, and yet the project outcome for that owner organization is really in the hands of the contractor. Now, when it comes to risk exposure of the contractor, things actually get even worse than simply just the execution phase risk, in that there is a huge amount of risk even during the bidding phase. In fact, it's actually less risky for a contractor to not win a job than it is to actually win the job. Conversely, though, contractors have to win jobs in order to make money. Now, during the execution phase, there is then an even higher degree of risk to the contractor. And so in many ways, it's a lose-lose scenario whereby the contractor has to competitively bid. So there's a huge degree of risk exposure there. But again, once the bid has been awarded, there is this secondary degree of risk exposure in the form of executing without eroding into contingency and margin. So historically, the way that planning process has come about, certainly from a contractor perspective, has been to leverage traditional planning and forecasting methods such as CPM scheduling, where we plan from left to right. As a contractor, we start with a given start date. We then determine the sequence of work. We assign costs and duration to those sequences. That gives us our critical path, and from that we then detail out the schedule. And I think one of the shortcomings of traditional planning is the fact that we end up with a compounding or a potential compounding delay effect. Even though from a contractor perspective, the risk is really primarily around execution, the contractor in many ways is actually held hostage by the preceding fabrication and procurement scope, and in turn, that procurement and fabrication scope is driven or is sequentially, again, held hostage by the upstream engineering scope. Any delay in engineering, procurement, fabrication leading to the delivery of materials in order to start execution, all of that has a very high degree of knock-on effect to the contractor. So what that means is the project completion date, and to a similar extent, the cost of project execution is highly uncertain. So in many ways, traditional planning from a contractor perspective has given the contractor a best case scenario versus a most likely scenario. And I think that's one of the reasons why today there is so much excitement around this, this next generation, this emerging science of what we are calling AWP, or Advanced Work Packaging. Now, I think one of the biggest differences between traditional planning and the philosophy behind AWP is the fact that we actually start from project completion and work backwards. The focus is entirely on supporting execution. So rather than thinking in terms of the traditional engineering, then procurement, then execution, then closeout, we start with closeout and we work backwards. We focus on what we need to do, how much time, how much money, how many resources will be needed to execute. And then from there, we work backwards and determine the supporting fabrication, again, durations and sequence and cost, and then from there work backwards in turn and look at the engineering scope. So really what we're trying to develop is a plan that fully supports contractor execution such that the contractor can execute in what we call a constraint-free environment. Many people will talk about AWP as really the alignment of people, materials, and location or space. All of these together, I believe, absolutely drive our ability to forecast with more certainty. And again, I think tied to that, what that means is from a contractor viewpoint is the plan they are marching to, it's the most likely scenario versus the best case. And because of that, the contractor has a much higher probability of achieving the as per plan execution because they're marching to that most likely versus being unfairly tasked to deliver simply to the best case scenario. Now, while AWP is a relatively young approach or a young science, the results from projects that have adopted AWP is actually quite remarkable. Contractors adopting AWP today are already experiencing up to 10% cost reduction, and I think even more interestingly, productivity improvement of up to 25%. Now, I've always been of the belief that productivity or poor productivity is not the root cause of project failure. It's the result of constraints such that the contractor cannot execute as per plan. Well, if AWP helps release those constraints such that materials and people are aligned and available at the right point in time, at the right location, then if that drives productivity up to, again, 25%, that has to be a massive step forward. Now, when it comes to the formal definition of AWP, organizations such as Construction Industry Institute or CII have arguably quite extensive descriptions and definitions. So CII touches on an overall process flow of detailed work packages, the fact that AWP is a planned and executable process that encompasses the work, providing frameworks for productive and progressive construction. While extensive, for me, I think AWP boils down to this. It is planning with the end in mind. It's an integrated and iterative planning and control approach for ensuring constraint-free, as per planned, predictable project execution. And I can't emphasize enough this concept of focusing on project execution. Really the early stages of a project, whether it's pre-planning or detailed planning, it's a dress rehearsal. We are getting ready for the actual execution of the project. So why on earth would we, as we have historically, focused on the dress rehearsal versus truly looking at, okay, how can we really execute this project? And what do we need to do during that dress rehearsal, whether it's pre-planning or planning, in order to properly model what's really going to happen when we get into the field and actually execute our project? I think the other very interesting aspect of AWP, certainly for a contractor, is the fact that for the first time, we are now marrying up and aligning front-end planning with work-phase planning. So front-end planning, it's really the big picture, long-term CapEx, cost and schedule forecast versus work-phase planning, which is our daily view as to what do we need to do in order to complete our planned scope. AWP brings those two together, and I think that's really, really key because I think one of the shortcomings of traditional planning has been that when we get into the field and we're in field execution, then contractors, while they are being tracked against a big picture CapEx, CPM schedule, or a big picture cost estimate, at the end of the day, they don't really follow that on a day-to-day basis. They follow their daily plans. So again, it's really the culmination of front-end planning and work-phase planning and aligning the two together. I think this is pretty self-explanatory, but in terms of why contractors should adopt AWP, I think there's three primary drivers. I think the first is very obvious: the reduction of schedule and cost. Those two are of course tied together, but it's a benefit not just to the contractor to come in on time and to budget, but also to the owner organization as well. The second bullet point, again, something very close to my heart, is this concept of increasing productivity, and again, productivity is not or poor productivity is not the root cause of project failure. It's the result of other stuff. So if we can fix those drivers, that other stuff, that will then reduce the risk of less than planned productivity, which gives us a much higher degree of confidence in our outcome, which ties to the third bullet point, the improvement of predictability. Again, I think projects are perceived to have cost and schedule overruns only because they're being compared back to overly aggressive, unrealistic forecasts. Again, cost and schedule forecasts. If we can improve our ability to accurately forecast, then we have a much better chance of achieving exactly as per expectation. Expectation, again, both from an owner and a contractor organization. Another benefit of AWP is the coming together and the alignment of owner and contractors. The fact that AWP is driving the chance of a successful triple constraint, the age-old triple constraint of time, money, and quality. I think the alignment between the outcome prediction, which is the plan, and the outcome reality, the execution, I think is so important. In many ways, the outcome prediction it's really, again, the expectation is set by the owner. The outcome reality, that's the responsibility of the contractor. And so by having input from the contractor during the planning phase and insight during the execution phase from the owner, massively brings together and aligns those two organizations. The fact that we're aligning engineering, procurement, and construction is a big deal. And again, I think the focus and the key here is that engineering and procurement should be serving the construction and the execution phase. And then ultimately, the alignment between materials, people, tools, and location. The fact that we can now have insight into, yes, the alignment, but probably more importantly, pinpoint where there is misalignment. Okay, we've got the right people, everything's in place, but the delivery of the rebar is such that we can't actually execute as per the plan. That's very powerful, because if we can pinpoint those misalignments, then we have a fighting chance of addressing them, deconstraining them, and again, that is all then going to enable higher degree of efficiency, or certainly efficiency as per the original plan or the agreed upon plan. So let's take a little bit of a deeper dive into the workflow behind AWP. Now, at the highest level, or the top level, we start with what we call a path of construction. Now, arguably, the path of construction is actually falls under the ownership of the owner organization. This is the owner organization at a very, very high level, determining the key deliverables and also the sequence in which those deliverables need to be delivered by the contractor in order to start up the project and go through project handover, again, from the contractor to the owner. To make that more manageable, that path of construction, in many instances, that path of construction may be modeled as, in this view, as perhaps 10 top-level elements. The second step is then to segment those path of construction elements into different areas. And again, these what we call construction work areas are geographical areas that may represent, for example, different trains in a refinery. Maybe it's as simple as an east-west segmentation on a linear rail project. Maybe it's different blocks within a road project. But really, the idea behind these construction work areas is that we're starting to make those very big picture level 1 path of construction elements more manageable for the contractor. Now, talking of contractor, when we get down to level 3, we're typically modeling down to no more than 40,000 man-hours. And those level 3 elements pertain to really the 3 key phases of the project. Now, engineering, procurement, construction, that's one thing, but the key to this level 3 here, again, from a contractor perspective, is we're going to focus on execution or construction, then we're going to backfill that scope of work with what is needed from a procurement and fabrication delivery perspective, and then for that, what do we need in terms of design and engineering to support that procurement? So those 3 steps can really all be grouped into what we call front-end planning. And I think, again, one of the the massive benefits of AWP is really now for arguably the first time, this isn't just an owner exercise. This is the contractor providing input into, okay, let's take those CWPs and let's articulate in detail what is needed from a procurement perspective, and when are those procurement items needed. Likewise, when do we feel comfortable that the detailed design should be completed in order to establish those fabrication items. So it's much more of a collaborative approach during the front-end planning phase of the project. Now, when we drop below the line into what we call work phase planning, this is absolutely really the ownership from a contractor viewpoint, because here what we're really modeling is, okay, against those bigger picture construction work package chunks or buckets, if you like, on a day-to-day basis and a very short-term planning perspective, what do we need to do? And those what do we need to do elements are modeled as what we call installation work packages. They themselves can be broken down into a further level in what we call daily plans or SIP steps. More on that in a couple of minutes. So let's look back and look at this concept known as path of construction, or POC. So again, just to reiterate, the path of construction, it is a logical sequence of events needed in order to support startup of the project. Now, I think the most important point to note about a path of construction is it is not just the critical path. Again, traditional CPM scheduling, we would detail out our work, we would look at the critical path, we'd focus on the critical path, and in many ways we would pretend to ourselves that that was truly the driving path of the project. Well, not necessarily. The path of construction looks much more at the sequence of the elements that are needed to finish the project. Some of those elements may not be on the critical path in terms of timing and zero float, but they're absolutely critical from this has to be finished in order for the project to start up. So there's a very important but arguably discrete difference between a critical path and the path of construction. And in many ways, I think, the path of construction, because it falls under the ownership of the owner organization, what the owner is doing here is they are setting the expectations that, okay, as a contractor, you need to fulfill the execution of the project to fit these very big picture buckets when you start to break out your work all the way down to those installation work packages. Now, to help with the development of the path of construction, at InEight, we're actually heavily leveraging artificial intelligence and machine learning to develop that POC. And in very simple terms, what we're enabling organizations to do is to digitize or to capture and digitize past historical project performance, whether that's in the form of historical as-built schedules or as per cost estimates, risk registers, so on and so forth, by storing that what we call unstructured data in a knowledge library and then leveraging the computer's ability to apply an inference engine to bring back and draw analogies and benchmark the top level or that top-down path of construction plan that we're developing. So what we're actually doing here is we're still giving ownership of the development of the path of construction to the planner, the scheduler, the estimator, the discipline lead, but at the same time, that POC is being validated by our historical performance. And our historical performance, of course, directly relates back to the contractor's ability to execute. Now, a really interesting aspect around the use of AI and machine learning with regards to the path of construction is not just looking at the historical durations and costs, but what we call rules of thumb as well. And what I mean by rules of thumb is when we start to detail out our path of construction and we start to look at our engineering, procurement, and construction work packages, being able to validate the overlap and the sequence of those is really, really important. What that means is when we're defining when our procurement delivery should arrive, let's look back at that historical information and take into account the projects where procurement came in a timely manner versus projects where procurement or late delivery actually had an impact on the contractor's ability to start the work during the execution phase. So again, using AI to validate the path of construction, the concept is very simple. The planner shares project context with the computer. So during the initial early planning phases, simply telling the computer, for example, the geographical location and or the type of project gives the computer some starting points against which it can then go off and mine analogous historical project. From that, the computer then suggests our path of construction sequence and timelines. Think of this as intelligent benchmarking. And again, I think to add to the mix here, we're not just coming back with historical timelines and sequences and overlaps. We should also be able to leverage risks that actually materialized on previous analogous projects such that we can proactively mitigate and reduce those risks, again, in the development of our project going forward. So the second level or the second step is then to segment our path of construction into manageable construction work areas. These work areas are typically multiple discipline or multidiscipline. Again, no more than around 100,000 man hours per construction work area segment. And I think it's, again, important to understand this isn't just modeling duration and cost. A CWA contains 2D plots or 3D models. It also includes things like required equipment lists and material lists on top of our plan forecast with regards to cost and schedule. Really what we're doing here is we're starting to break down that path of construction such that when it is handed over to the contractor themselves can better manage those segments of work. The third level then is the development of construction work packages. Ultimately, a CWP is really a contractor instruction of work. We're changing here from defining scope and deliverables and now focusing on the work needed in order to deliver those deliverables and those scope elements. So again, typically no more than 40,000 man hours. And just as we saw with the construction work areas, this isn't just information pertaining to durations and cost. Again, this is drawings and models. And now we're actually getting down into the level of detail where we start to model who is required from a resource perspective, the number of man hours required. We're truly getting into the detail of the work. And I think because we're getting into this level of detail, it's really only beneficial to start modeling CWPs at a point where we are no more than 90 days out from the execution of those CWPs themselves. So don't waste time modeling down at this level until you need to. Again, use that 90-day mark really as a benchmark as to how far out should we be planning in detail our execution. So I mentioned that engineering and procurement work packages are really, the objective here is to provide supporting work elements in order for execution to be constraint-free. Think of this as backfilling your plan that contains your construction work packs. Here what we're doing is we're de-risking the compounding sequence that I alluded to right at the beginning that traditional project planning really doesn't address. And again, this rules of thumb, I think, is such an exciting, groundbreaking concept within planning because we're not just looking at the durations and costs associated with engineering and procurement work. We're actually aligning the sequence such that we're giving ourselves enough time for engineering to pass over to procurement and fabrication all the way to delivery. I think this concept of when engineering and procurement work should be carried out is actually more important from a planning predictability perspective than simply forecasting accurate durations and costs. We may get the durations absolutely spot on, but if the point in time at which those durations are executed is out of whack, then our plan is fundamentally flawed. So again, at InEight, we are leveraging artificial intelligence and machine learning to help better develop those supporting engineering and procurement work packages. So think of this as really intelligent subnetting, being able to draw from a knowledge library and pull in those subnets with logic, with required resources, with associated costs. Again, historical risks pertaining to that scope of work, and subsequently then being able to sew all of those subnets together in order to build our truly free-flowing, constraint-free construction, engineering, and procurement work packages. The concept of risk intelligence, I think, is, again, another very, very interesting area, and it's something that AWP has absolutely embraced. So, looking back maybe 20 years ago, the planning maturity in the construction industry was, okay, well, let's adopt things like CPM, and that will give us a sequential set of activities. That will be our schedule. And I think, what people have realized is, again, that produces the best case scenario, not the most likely case scenario. So fast forward, really, I would suggest to the last 5 years, and I think now the concept of risk-adjusted scheduling is absolutely becoming mainstream. Now, when it comes to, execution, again, performance is relative to our original plan. One of the downfalls of traditional planning has been that, plans undergo quantity growth as the plan gets more detailed. And in many ways, that quantity growth is really one of the biggest risk drivers within a CapEx project. So what we're doing now is we're actually leveraging historical project information to calibrate and adjust durations based on associated quantities. And again, applying this then to generate a risk-adjusted path of construction, which then flows down into our work packages, all the way down, as you'll see in a minute, into the field, where literally our installation work packs and our daily plans are taking into account now risk and potential quantity growth relative to the earlier phase plan. Ultimately, what this is doing is driving confidence. And I think one of the very exciting areas with regards to machine learning is then out in the field, as the contractor executes the work, those as-builts and those as-achieved productivity rates can automatically feed back into your organization's knowledge library. That in turn makes the AI and the machine learning even smarter the next go around. So here's an example of a very interesting report that is really reflecting the risk-adjusted path of construction. So the thin segments here are showing what I call the deterministic. This is the view of the project without taking into account risk and uncertainty. And then the thicker rectangles reflecting the risk-adjusted. And in the world of risk analytics and viewing a project through the lens of risk analysis, rather than just looking at a single scenario, one of the benefits of developing a risk-adjusted path of construction is that we get a range of outcomes from absolute best case to absolute worst case. And in the risk world, we call this P0 to P100. And I think, again, one of the massive benefits of risk-adjusted forecasting, certainly within the context of AWP, is that owners and contractors can now agree on, again, a schedule and a cost forecast within a given confidence level. So, as a contractor, I am willing to accept and undertake the owner's target dates and schedule against perhaps a 75% certainty or confidence level. Likewise, during that engagement or agreement, the owner organization has a 75% certainty that that agreed upon date and cost forecast won't be exceeded. Well, that's a very, very big step forward with regards to executing upon expectations and a contractor's ability to deliver as per the plan. So obviously, when it comes to field execution, the contractor is now taking that bigger picture CapEx forecast and really moving from front-end planning to field execution planning. And this is where the introduction of what we call installation work packages come into their own. Again, this is a further breakdown of that planned scope of work. I think what's important to note here is we're going well beyond just looking at how many man hours are required to execute the work. An IWP, or an installation work package, also describes and includes the materials and the tools and the components that are needed to execute that work. Well, again, that's a big step forward in the world of planning. Historically, we've focused on perhaps man hours or duration, but then the concept of, well, what is needed from a material perspective and what is needed from a tool perspective to execute that work has never really been incorporated into the plan. Well, it is now with the concept of installation work packages. So the bringing together of the right people, the right materials at the right time in the right place. This is where the rubber hits the road. It's all about installation work packages. And then again, associated with this concept of IWPs or installation work packages, taking it down to the lowest level of planning, this is when we get into what I call short interval planning or daily planning. Once those IWPs are constraint-free, so in other words, once we have ensured the material is ready, we have the right resources, the construction area is available for execution, then those IWPs can actually be broken down into daily steps, or what we call SIP steps or daily plans. And here is an example on the screen where those blue elements, those IWPs, they span perhaps several days, but then the foreman or the superintendent can now, on a crew by crew basis, start to break out those IWPs into daily plans. And again, I think what's so powerful here is we're not just looking at required man hours. This view can tell a foreman or a superintendent, again, okay, how much material availability do we have? Do we have the right equipment in place to execute this work on a daily basis? And if we don't, the foreman and the super and the crew members can actually report back using what I call these digital post-it notes. They are digitally magnetic, where a person in the field can literally drag, drop. They can extend these daily plans. They can annotate. They can take photographs as to why they weren't able to execute as per the IWP plan. This is a very, very effective way of providing feedback from the field back to not only our IWPs, but then those IWPs roll up back to the construction work packages all the way up to the path of construction. So what does that mean? What it means is, again, in real time, we get feedback as to how closely aligned is the execution of the contractor to the agreed upon plan that was developed through that path of construction, through the CWPs, all the way back to engineering. So a lot of buzzwords in the AWP arena. I think two buzzwords that are being touted a lot right now: digital thread and digital twin. And I think they're both very interesting and both very relevant to this discussion. So think of a digital thread. Really, it's the record of, well, the formal definition is a digital thread as a record of a product or project timeline from creation to its completion. For me, I think a digital thread is all about representing the timeline of the work being executed. A digital thread is more relevant to a contractor 100%, because what it is it's the capturing of the work that was executed, the people that executed, the materials, the labor, the location, the weather, risks that arose, so on and so forth. A digital thread is all about coming up with an audit trail of the work. So it's a snapshot really of the effort that the contractor has consumed or expended when executing the work. Now, that's very different to what we call a digital twin. A digital twin, by definition, is the current representation of a product or asset or project mimicking a company's machines, control, workflows, and systems. So what does that mean? What that means is this is a timeline of the asset being delivered. An owner cares about the asset being delivered. A contractor ultimately cares about the effort, time, and cost that they have to put into the project in order to deliver that asset. So a digital twin really presents massive value to the owner partner or the owner organization, whereas the digital thread is a record of the contractor performance. And the two are both very, very relevant. They are synergistic. Understanding the components of the asset, yes, obviously important to the owner organization. That's your digital twin. But also, even from an owner perspective, understanding how we got there through the work that was executed. In other words, the digital thread, the contractor view is equally important. So I think some takeaway comments or thoughts, without a doubt, AWP better aligns contractor execution with owner expectations. It's driving a much more collaborative relationship to the point where ultimately I think we'll start to think of owners and contractors or owners and EPCs. They're essentially part of the same business unit. They're all marching to the same tune, and the transparency and the continuity of data that AWP enables is really night and day from traditional planning. When we look at the AWP acronym, let's take it very literally. It is an advanced way to plan, but yet, we're not turning planning philosophies or concepts on their head. AWP, it's an advanced way to endorse and really we're extending those traditional CPM planning techniques. The focus is on work. So, the focus is on execution, and it absolutely should be, because ultimately we care about executing the project so that it can be turned over from the contractor to the owner. The owner then receives that asset. Let's drive everybody's focus on that project on constraint-free execution. And thirdly, it drives the bundling of work into manageable packages. It breaks down, it details out what could potentially be a multi-billion-dollar scope project into manageable packages that can be adequately and appropriately executed by the contractor. Traditional project management, the thinking has always been, well, let's plan the work and then work the plan. That's very much a sequential way of managing a project. AWP is different. AWP is really all about better planning the plan so as to better work the work. And I think the concept that we are continuously planning even during execution. And I think finally, to add to the mix, the fact that at InEight, we are taking a knowledge-driven or a knowledge-guided approach to AWP. We're enabling organizations, both contractors and owners, to take advantage of the good things that happened in the past and also avoid the bad things that happened on prior projects as well. So this concept of marrying up artificial intelligence and machine learning from a technical perspective with this emerging and next generation planning concept known as AWP, I think together those two are a huge step forward. And again, the early results from projects that are adopting AWP is it's very hard to challenge. So I hope you found this webinar useful. Again, the focus was around the benefits to a contractor organization, but equally, there are contractor benefits that spill over into providing better insight to the owner organization. And anything we can do as an industry to bring together and better align owners and contractors is ultimately going to improve the science of project management. Thank you all very much.
Thank you, Dan. Again, if you have any questions about the webcast, please email them to webcasts@InEight.com. To learn more about InEight, as well as our planning, scheduling, and risk solutions, visit InEight.com and click on the Request a Demo button. And if you'd like to see a schedule of upcoming webcasts, visit InEight.com/webcasts. Thanks for watching. This concludes our presentation.